So what we're about to do here is learn that our inverse trig functions don't behave as nicely as we would like. So if I had given you all no instruction here to fill this out, most students would probably just write that these are all equal to x, okay? Which is what we want when we're working with a function and its inverse. But it ends up that this isn't always going to be the case. And this is because when we think about sine inverse and cosine inverse and tangent inverse, we've restricted the domain of sine, cosine, and tangent. Okay, so this can't be true for all x. Okay. So let's try this first one. The domain for sine inverse is -1 to 1. If you plug in anything outside of this, sine inverse will be undefined. And as a result, sine of sine inverse of whatever x was will also be undefined. So we have to stick with numbers in between here. And actually, I'll write that in a different color so we don't mix it up. Okay, this is 4x in -1 to 1. Now, next here we have sine inverse of sine of x. Okay, and at first glance, it seems like this one would be true for all x because you can see, hey, I can plug in any angle I want into sine of x, right? Sine of x, its domain, if we're thinking about it as a function, its domain is all real numbers. You can plug any angle in. Okay, and so that's fine and all, but then when we get to sine inverse, you have to remember it only gives you back certain angles. It only gives you angles between -π/2 and π/2. So if this angle x here is anything outside of that range, we're not going to get the same x out. And if that doesn't make sense yet, we're going to do some examples, and I think it'll solidify that idea for you. But let's write in here 4x in the interval -π/2 to π/2. All right, next let's move to cosine. And actually, let's look at cosine inverse of x first. Its domain is also -1 to 1. And so we're going to have domain issues if we go outside of this. Okay, we'll be undefined just like the first one. So this is 4x in 0 to pi. Okay, and one thing that I didn't point out actually about the first one was, well, if we do plug in something between, oh, I wrote 0 and pi. Let me fix this. All right, if we take some number x that's between -1 and 1, right, cosine inverse will output something that is in between 0 and pi, right? Okay, and so if it does that, well, cosine can input any angle. So if we take anything from here and plug it into cosine, it's fine. Okay, so our only worry really was about cosine inverse. We didn't have any worries about cosine here. All right, and that being said, I had it there, but if we look at the next one, you know that cosine of x for any angle, it'll have an output, right? Its domain is all real numbers. Okay, but it will output, right, numbers that are between -1 and 1. And so these are the numbers that are going to wind up going into cosine inverse. Okay. Well, cosine inverse can only give us angles between 0 and pi. So if this original angle that we start off with, x, is anything other than an angle between 0 and pi, this isn't going to work out. So 4x in 0 to pi. And let's go on to tangent. in tangent inverse. So if we're looking at tangent inverse, well, it has a domain. Do we remember what the domain was for this? It was all real numbers. So anything we plug into tangent inverse is fine. And the things that tangent inverse is going to output are going to be numbers that are between minus pi over 2 and pi over 2. And again, when I take in those numbers that are between minus pi over 2 and pi over 2, tangent is fine with that. Okay. So this is actually 4x in minus infinity to infinity. So in other words, all real numbers. This is the only one of these that is true for all x. Okay. And the next one we want to think about now, tangent, right? If I do tangent of x, what do my outputs look like? Okay. Well, if I take tangent of x, my outputs can be actually anything between minus infinity and infinity. Okay. And then tangent inverse can take in those numbers. That's the domain of tangent inverse. But the problem is that tangent inverse will only output angles that are between minus pi over 2 and pi over 2. So this is only true for x values that are between minus pi over 2 and pi over 2. All right, now let's go and do some examples and see why this is happening. All right, let's see if we can understand what we wrote up above. Okay. And really, you don't have to memorize what was on the previous page as far as when, sine of sine inverse of x actually works out to be x. You can just remember those restricted domains and it'll help. Okay. And we can do this process that we're about to do here. So let's start off with finding cosine of 5 pi over 4. Okay. So 5 pi over 4, that is right here. And cosine's the x value, so minus the square root of 2 over 2. Let's go take care of that. So this is equal to cosine inverse of minus the square root of 2 over 2. So now is what we want to do is we want to find the angle theta such that cosine of theta is equal to minus the square root of 2 over 2. But remember, this theta here has to be between 0 and pi. Okay. So we need to find a spot on the unit circle where the x value is equal to minus the square root of 2 over 2, and we're in quadrants 1 and 2. All right, and if we do that, minus the square root of 2 over 2, that looks like it's happening right here at 3 pi over 4. Okay, so that is our answer. This is equal to 3 pi over 4. Okay, and so this worked out this way because this 5 pi over 4 is not in between 0 and pi. If it was, this would have worked out perfectly, just like this next one's going to, right? This pi over 6 is actually an angle that is in the desired range that we want. Okay, so our angle theta, or pi over 6 here, is actually between minus pi over 2 and pi over 2. So this should give us pi over 6, but let's again check. So sine of pi over 6, if we went and looked at our unit circle, we would see that sine of pi over 6 is just 1/2. Okay. And now remember, if we're trying to find sine inverse of something here, is what we're really looking for is we want to know sine of what angle is equal to 1/2. And remember, that angle has to be between minus pi over 2 and pi over 2. So we need to look in quadrants 1 and 4 for an angle that corresponds to an x value of 1/2. Okay, and if we're only in quadrants, I think I might have said quadrants 1 and 2. I meant to say quadrants 1 and 4 there. But if we are in quadrants 1 and 4, right, in between minus pi over 2 and pi over 2, the only y value that is 1/2 is this one. Okay, in these two quadrants, it's the only y value of 1/2. Okay. So our answer is going to be the angle pi over 6, which is what we had started with. Okay. And then next on our list here, we have tangent of cosine inverse of minus 1/4.